Alrighty, in this video, we are going to be talking about inverse functions and the background of inverse functions. So in this video, I'm only going to do example 1 and give you the background and the runaround of it. And then in another video, we'll do some other problems. I'm not going to do all of these because they get pretty repetitive in terms of what you guys are doing. Now, as a reminder, back in Math 3, if we have an inverse function, it needs to be 1-to-1, which means that it passes the horizontal line test. In addition to that, this means that you have f of g of x is equal to g of f of x, which is equal to x, which means that g of x is going to be the inverse of f of x, or vice versa, depending on what they are. So what we're going to do is take the derivative of both sides with respect to x for f of g of x is equal to x. Then we're going to solve for g prime of x. So if I take this derivative right here, remember that this is just the chain rule. So I have f prime of g of x times g prime of x is equal to 1. And if I'm solving for g prime of x, then that's going to give me 1 over f prime g of x. Now, the reason why I did that is to show you that this right here is going to be the inverse derivative. Because remember that if g of x is the inverse of f of x, then g prime of x right here represents the derivative of the inverse. So the derivative of the inverse is going to be equal to 1 over f prime of g of x. And in addition to that, we're going to recall that if f of x contains the point AB, then f prime of x, not f prime of x, the inverse of f, in this case g of x, will contain the point B comma A, because it is a reflection across the line y is equal to x. 1a is going to be me finding the inverse and then taking the derivative of the inverse at 7, essentially. So what we're going to do is restrict the domain and find the inverse of f of x, and then we're going to evaluate that at 7 for this function right here, where we have a restricted domain of x is greater than or equal to 2. Now, here's the thing about this one right here. Remember that x squared minus 4x plus 10 is a parabola. And this is going to be x is equal to 2. So in order to restrict this, I'm going to restrict it from this right here. But in order to do that, I kind of need it in vertex form, because if I were to switch x and y right here already, this is not going to work out for me, because then I have 2 y's and that's going to get pretty messy. Because either way, you're going to have to use completing the square now or later. And I choose now. Completing the square, guys, does not go away. I promise you. It's not going to hurt you to remember this. It's one of my favorite topics because I love teaching completing the square in Math 2. Like, it's so much fun. You have 4. It needs to add up to 10. Guess what? That's 6. So now I have x minus 2 squared plus 6 is equal to, of course, let's say y, or f of x. To find the inverse, I'm going to switch x and y. So now I have y minus 2 squared plus 6 is equal to x. And then I'm going to solve for y, which in this case is going to be my inverse. So I have y minus 2 squared is equal to x minus 6. I'm going to take the square root, and then I'm going to add 2. Now, you'll notice that here, I did not include a plus or minus whenever I took out the square root. And remember, that's because my domain is restricted for x is greater than or equal to 2. If I use plus or minus, then my problem is going to look something like this. And remember, that's not going to be a function because it doesn't pass the vertical line test. So we have the inverse being the square root of x plus 6 plus 2. I'm going to take the derivative of that. The derivative of 2 is just going to be 0, and then the x plus 6 is going to use chain. So the derivative of this is going to be 1/2 x plus 6 to the negative 1/2 And if, not plus 6, sorry, minus 6. And if I were to find the derivative and plug in 7 right here, because that's what I want, the inverse derivative at 7, then I'm going to have 1/2, 1 to the negative 1/2, which is just 1/2. So this is telling me that this right here, f inverse of 7, the derivative of f inverse of 7 is going to be 1/2. And notice how this kind of took us a while. That's why we want to use this formula here that we just derived 2 seconds ago whenever we said that, hey, g of x is the inverse. Okay, then g prime of x is the derivative of the inverse. That's going to give me 1 over f prime of g of x. So let's look at part B and C together because they go hand in hand. Part B says, recall that the inverse, f inverse of 7 means f of x has a coordinate of x comma 7. Because remember that this represents your y coordinate. So what we're going to do is set the y coordinate equal to f of x and solve for x. Now there's a reason why for that. Because if I were to take the derivative of this, I'm going to get 1 over f prime of g of x. And if I were to plug in 7, I'm going to get f prime of g of 7. Well, g of 7, we kind of don't know what that is because g of 7 is going to be your inverse function. And if that's going to be your inverse function, 7 is going to represent your y, which is why here we need to find out what x is. Because whatever x is right here, that's going to give me my y for my inverse. All right, so I'm going to set this equal to x squared minus 4x plus 10. That's going to give me x squared minus 4x minus 3. That's going to give me x minus 4, x plus 1. And that's going to give me, oh no, not 4, 3. And 1. Oh my god. There you go. Sorry. X squared minus 4x plus 3. X minus 3 and x minus 1. That's going to give you x is equal to 3, and that's also going to give you x is equal to 1. Now you want to pay careful attention to this because my restriction is x is greater than or equal to 2. So 1, I don't care about her. She's irrelevant in this case. So this tells me that f of x has 3 comma 7, which means that f prime of x, not f prime of x, f inverse of x has 7, 3. Or in this case, g of x. So that's going to tell me that g of 7, or f inverse of 7, is 3. So now I have g inverse of 7, or g prime of 7, is equal to 1 over f prime. And then we just said that g of 7 is going to be 3. We're not done yet, because guess what? We need to figure out what f prime of 3 is. So we're going to take the derivative of f of x. And that derivative here is going to be 2x minus 4. And then we're going to find out what f prime of 3 is. Oops, not 6 minus 4, 2. So if f prime of 3 is 2, then g prime of 7 is equal to 1 over 2, which we had earlier. I know this might sound confusing, and you might think that this is a lot of steps in terms of B and C. However, I like this more than you completing the square, finding the inverse, and then taking the derivative of the inverse. Now, this, if you want to do that, that's fine. This is a valid move because you still get 1/2 of your answer. But if you know the relationship between g prime of x and f of x, aka part B and part C, then it should go pretty quickly because you're going to be doing the same thing repetitively, which we are going to be doing starting with number 4. I'm going to do a couple of these problems because, like I said, they get repetitive. So all you have to do is just do practice with these problems and you'll be okay. I wouldn't say that this is a hard topic, but you just got to remember what the steps are to find the derivative of an inverse. So in the next video, we'll talk about, let's say, 4 and 5 or 6, and then we'll call it a day.